In this video, we're going to have a look at how we can graph non-linear relationships. So in the previous videos, you would have had a look at graphing linear relationships. And when we mean linear, we mean that they form straight lines when they're visualized. So in this video, we're going to look at we're going to look at equations or relationships that aren't necessarily straight lines. So they could look something like this, they could look something like that, they could look something like this. It all really depends on how the relationship is depicted. So over in example 1a, it says a relationship is described by the following equation. So y equals x to the power of 2. Using a table of values, plot the graph, and then secondly, verify your plot using technology. So to start off with this question, what I'm going to do is I'm going to quickly draw up a table. So I'm going to go table like so, and then we need to populate the table. So we need to get our x and y values. So our x values go here and our y values go here. Now it's saying to plot the values. Now when I look at a function like this, I have to ask myself, what is the easiest functions to determine? And instantly the first one that comes to my mind is simply when x is equal to, say, 0. That's quite an easy one to work with. So I'll put 0 over, put it here so we can space it out a little bit more. Now, because I've chosen 0, what I'm going to do is I'm going to pick some values going up. So we'll go 1, 2, and then 3. And then similarly, we'll go -1, and then we'll just go -2. It's a little bit asymmetric here, but we should be able to get a general trend of what's going on simply by investigating what these values equal. Now, to populate the rest of the table, what we need to do is we need to synthesize some results. So what that means is, well, we have to write out the equation y equals x squared. And then we're going to substitute in the values of x here to calculate the values of y. So when x is equal to 0, the value of y is going to be 0 squared, and therefore y will be 0. So I can throw a 0 in there. Now when we have x squared, when x is equal to 1, the value is going to come out as y is equal to 1, and this will continue on. Now, it's really tedious to do all of the calculations for this, so what you might find is it might be a little bit easier to, rather than writing out all those calculations, is you can get up your calculator and you can simply throw them in the calculator. So we'll go exit. Then this is a fancy calculator, by the way. It does the graphing, so this is what you'll be using in year 10. So I can go to run matrix, and then I can simply input the equations in here. So the first one I've already done them, so we'll go 3 squared now. That will come out as 9. And now I have to do the negative values. So what we'll do is we'll go -1 all squared. That will come out to be 1. And then we'll go -2. That's going to come out to be 4. And I've made a mistake here. That should be 4 as well. Alright, cool. So now that we've got our table of values, what we can do is we can start plotting them. So when x is 0, y is 0. 0, 0. When x is 1, y is 1. So 1, 1. And when x is 2, y is 4. So all the way up there. Similarly, plotting the ones on the left-hand side of the 0, -1 and 1. And then -2 and 4. Perfect. Now to finish it off, I need to draw a curve that goes through all of these lines. So do like a dotted line and make sure it cuts through all of the lines here. And what you can clearly see is we've got a relationship that clearly isn't a straight line. So what we're looking at is something called a non-linear relationship. You'll see this particular curve when you get to year 10, and it's called a parabola, but that's for later. Now, the second part of the question says verify the plot using technology. So what we can do is we've got two options. We can use these fancy calculators, or we can use Desmos. I'm going to show you with this calculator first. So I'm going to go to Menu, then I'm going to go down to Graph, and then I'm going to hit Execute. From there, I've got all of these options to input graphs. What I'm going to do is the relationship is y equals x squared. So that means I have to go over to the X button here. I'll click that, and then I go here to squared. Then I'm going to execute, and then finally I go up to F6 and it says draw. I'm going to click on that. And lo and behold, we've got a funny looking line that resembles what we've drawn over here. Now, this is a really old calculator, so the display's not that great. If you're lucky enough to have a modern calculator, one of the nice white ones, then the display itself, it'll be in color, a higher resolution, and much easier to read. But nonetheless, the features on these calculators are the same as the modern ones as well, so they're still applicable. What I'm going to show you how to do is how to navigate the menus now. So if we want to get in for a closer look here, I can go to F2, zoom, then I can go auto, and it will automatically adjust to see the features of the graph. Using this little D-pad, I guess you'd call it, we can move up and down to scroll around the graph itself. And if we want to pull features off the graph, we can go to F5, so Gsolve, and then if we wanted to see where it touches the x-axis, we can press F1 for root, and it tells us the coordinates here. Or if we want to see where it cuts the y-axis, then we can go to this one here, y-intercept, F4, and it will tell us where it cuts. So you don't see them a lot in year 9, but starting in year 10, you'll get to use these calculators a little bit, and then in year 11, these calculators will be your best friend. Alright, cool. Now if we do this in Desmos, what we'll find is that I can simply type in y equals x squared, and the relationship is as such. So Desmos is it's a lot easier to use than these calculators, but you don't have access to Desmos during a test in year 11 or year 10 for that matter. So it's better to learn how to do it on this technology here. And when you're going for, or when you need really good detail during your study, you can use Desmos. Alright, so example 1a, that's now out of the way. Let's have a look at example 1b. Same sort of question. A relationship is described by the following equation, y equals x to the power of 3. Now, using a table of values, plot the graph, and then verify the plot using technology. So once again, we got to draw a table. Do it nice and big this time. And I have to put in values. So again, notice that the easiest value to determine here would be 0. So we'll just center the entire thing around 0. So I'll put a 0 there. Then we'll count up by 1, 2, 3. Then -1, -2, -3. And then x. And now these are my y values. Alright. So rather than showing the full working out, what I'm going to do is I'm just going to throw in some values here. So I'm going to go back to menu, up to my run matrix, and then I'm in this screen here to put the values in. So what I'm going to say is x to the power of, oops, not x, go brackets to the power of 3. Then I'll put in 0, and 0 to the power of 0, or 0 to the power of 3 is simply 0. Now let's go for 1. And and lo and behold, it's 1. Going for 2, and we find that it's 8. So what we find is these values, they're the same as saying like 2 times 2 times 2, or in this case 3 times 3 times 3, and I can do that in my head and it's simply 27. Now similarly, we've got to go these negative values. So if we said, say, y equals x cubed, and then we said let x equal -1, then what that's going to come out is to -1 all cubed, which is -1 times -1 times -1, and that's just -1. So what we find is the values here are mirrored about 0, but they come out negative. So that will be -8, and this will be -27. Now plotting this particular graph here, notice that it's way off the scale. So the first one here is 0, 0. Then the next one is 1, 1. And then the next one too, it's somewhere probably up there. Let's just put it here. And that will be 2, 8. This one over here, it is -1, 1. And then we go all the way down there somewhere. Alright, so if we're trying to draw a line that fits all of these points, then what we find is we get something that looks a lot like that. And this particular function here, we call it a cubic, but again, you don't really study this in year 9 as such, outside of simply just plotting 1 or 2 there to understand that there's something called a nonlinear relationship. You will see this a lot in year 11. You might see it in year 10, but yeah, you'll see this quite a lot in year 11. Now if we go to graph this on our calculator, go to menu, graph, and then I'm going to type in x to the power, so this one here, to the power of 3, then execute, then F6 for draw. What we find is this funky looking function here, which is consistent to what we plotted over here. And then to get a better view, I'm going to go to zoom and then just set it to auto and let the calculator do it for me. So yeah, this is, we find that the graph itself is consistent with what we plotted over here. Now if I wanted to get a different view, I can move the D-pad around like so. Or alternatively, I can go to zoom and I might want to zoom out, click out, then go exit. Zoom, out, execute. And that will allow me to go in and out. Similarly, I can adjust this manually by going to F3 into window. And I can manually set it to say minimum of -3, maximum of 3, and then down to Y min and Y max. I can set it to the values I've got here. So Y min would be -27, and then 27 there. Exit, and then draw, and I've got the window focus to all of the points that are plotted here. So this has been what should have been a brief video, but 14 minutes isn't too bad. This has been a video showing you how we can plot nonlinear relationships and then how we can evaluate whether we've done our plot correctly using technology with these calculators here, which you'll use in year 10 and a lot in year 11, and as well as how to do it in Desmos here.